Hello everyone, welcome back to the channel Kanu sir, and I'm back again with another topic from grade 10 chapter 4, and the topic is Newton's universal law of gravitation. So what is the concept here is that Sir Isaac Newton, he got to a conclusion that there is a gravitational force between any of the objects, between all the objects in the universe in each other. It means that the gravitational force between any two objects, if we take example of any two objects, we can take example of all the objects in the environment, but let us take an example of just two objects, that is object A and object B. Then there is the force of gravitation between them is directly proportional to their product of their masses. So let us assume the mass of A is m1 and the mass of B is m2, and there is a distance between them, that is d. I have taken the distance between them from their center here and here. What is explained is that here the gravitational force is directly proportional to the product of their masses. It means if the product of masses increases, then the gravitational force will also increase, and inversely proportional to the square of the distance between their center. It concludes that if the distance between the objects will increase, then the gravitational force will decreases, and if the distance between the object decreases, then the gravitational force increases. That is why it is also called universal law of gravitation. So you can take an example of this marker and me. This marker is attracting towards its center, and I am also attracting this marker towards my center. Here is the problem, that this marker is very small and its mass is very less. So mostly here in the examinations and in this chapter, we take an example of heavenly objects like the sun and the earth. So when we take the example of sun and the earth, then the gravitational force between two objects can be measured with the formula G m1 m2 upon the distance between from the center of sun to the earth is d, by using this formula. And in the same case, if the two heavenly objects, and the same formula can be utilized into small objects also, like their ball A. If they are small balls, ball A and ball B, then the gravitational force between these two objects will be taken as G m1 m2 upon d square. I forgot to write here square. Similarly, if we take earth, simply earth, that is m, and if we take a smaller object like us, we are very small in comparison to the mass of the earth, then this small m, and the distance between the center of the earth and our body will be considered as equal to the radius of the earth, because the distance from our body to the earth's surface will be considered as negligible distance. So the formula for gravitational force between the earth and our body will be considered as G capital M small m upon r square. And hence these all the three different formulas which seems different, they are actually same, and it is applicable in all the objects in the universe, and hence it is also called universal law of gravitation. And there is one more point, that is capital G. What is this capital G? It is called gravitational constant, and its value is fixed, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. It is a scalar quantity which is a constant value everywhere. It doesn't change because of any type of external force or pressure. It will never be changed in temperature, neither it changes due to change in the masses. It means whatever the mass will be, there will be no change in the capital G, or we can say the gravitational constant. So this much for this topic today. If you have some other questions related to this topic, you can put in the comments below, and keep practicing, keep learning. Bye.